So I'm going to put an oil pressure gauge either here or here. It's not recommended you use Teflon tape for sealing the threads when there's oil involved. So I'm going to use a thread sealant that stays, it's high temperature, it stays very slightly flexible, Permatex. This is just a cheap mechanical pressure gauge. This is a 1/4 NPT fitting. NPT stands for National Pipe Thread. Clearly it's more than 1/4 of an inch in diameter. The quarter doesn't refer to the diameter, but there are lookup tables on you can Google which show you what diameter a particular NPT thread is, so you buy the right one. So this should fit into one of these ports. You see, it looks like it's got a sporting chance of being the correct thread size, so we'll see how we get on now. So there we go, that's my oil pressure. This is a blanking plug, so that should be good enough for the initial test runs. Got my radiator in. Someone lent me this. It's not in the best shape, but it doesn't actually leak, which is good. The drain tap needed a bit of greasing, but apart from that, that closes now and doesn't leak. So I've got my bottom hoses on, top hoses. Water comes out here, usually sort of 90-degree bend or 45-degree bend up to here. So I'm going to keep it simple. I've got some 90-degree bends coming. I'll probably just run them, stretch them out slightly so that there's a little bit of an angle on the top pipe. Then I'm going to use a metal tube here and just a straight piece of rubber connecting tube here. You're meant to put thermostats in here, one each side. These ones open at 160 degrees, that's Fahrenheit, and there's different ways of holding them because you don't want them to sort of migrate up the hose or twist or jam. You can see there's this little grommet thing here, which I think should move freely. Again, I don't want it to get jammed. So you can put the hose over it, and the hose, when it's done up with the Jubilee clip, should grip it. It does feel slightly wider in diameter than the metal casting, so I would expect the hose to grip it. I could put another Jubilee clip above the lower one and just grip it. The other way is you get a piece of pipe, hose the same diameter, and you put it over it like that, just a short piece, and then you put that inside your larger hose, and it just pushes it down and keeps it down. However, to be honest, I think a piece of squishy hose would actually grip this, especially if I put a second Jubilee clip above the main clamping one. Can't see how this is going to go anywhere. So I'll wait for the 90-degree bends to come and then decide what I'm going to do there. So apart from the wiring, the other thing I've got to think about is the fuel delivery. So this is the fuel pump. There's like a push rod and a rocker arm here inside, which acts on a diaphragm. The connections are solid in these old cars, so I've just got a thread here, so I've got to supply fuel to that. So again, I went on the forums and looked around, and what I need is some of these. They're just called Ford nuts by the look of it, but you can see they screw in, but they have a little olive which then compresses the hard line. So I'll have some hard line coming out, and then that will attach with a bit of bodgery to a boat tank system for a small boat with an outboard motor. And this also has a priming squeezy thing in it, which is quite helpful because I can hopefully prime the car before I start the engine without having to just pour fuel down it. Got this boat tank idea off from Derek Bieri of Vice Grip Garage. He's a guy that gets a lot of old cars going that have been in ditches or abandoned, and he'll often run them off one of these tanks so he doesn't pull rubbish and rust through from the actual car tank that's been sitting for years. So I need to just check that these do actually fit the fuel pump. So first of all, have I bought the correct pipe, and do the olives just fit over it? And the answer to that is yes, so that's good. So the next thing is, does this fit into the fuel pump? Kind of hoping it will. It should do. Yeah, promising. Yeah, I would say that does. Good. So that's how I'm going to do the fuel. So jobs left: fuel, top hoses with thermostats. I've got a cheap electric fan which I'm just going to cable tie onto the front of here or something. Not quite sure how yet. Not going to run the generator. I'm going to run everything off 12 volt, 12 volt coil, which will be temporarily mounted somewhere. I've got a electronic distributor that's 12 volt. I've actually invested some money in that. And the starter motor, you would think you need to convert it to 12 volts somehow, but actually people just run them off 12 volts. So maybe I should keep the amount of starting down, stop it burning out, but you know, in short bursts, that's okay. I have in fact got the means to add a good old-fashioned crank handle if I want to. There's room under the radiator for me to make a crank handle. I might even make one just for fun from an old scissor jack handle or something. I've got a length of tube to extend the exhaust a little bit, and yeah, well, that's it really. I'm going to pull all the plugs, slowly turn the engine. You can see the edges of the valves, check the valves move, and sometimes they stick, so I need to check that they go back, because compared to modern cars the springs are actually quite weak. And then I'll probably pop a little bit of oil down each bore. I'm using a high zinc oil. I've already filled the engine up and nothing's leaking out onto the floor. Do you remember I fitted that copper crush washer under there, where the oil bleed plug was, and that seems to be working. I need to build a little control panel with an ignition switch on it and an ignition relay. I might buy a choke cable, just so I've got a proper choke and a nice little control panel, and then we'll be about ready for maybe a test run. I've just welded this up from scrap steel. Basically there'll be a control panel which will bolt here, made of wood or polycarbonate or something, and have ignition switch, relay, yeah, stuff like that. It's just a convenient place to put it. I'm a big fan of the Vice Grip Garage channel. This is a guy that rescues old cars from ditches and fields and gets them running again. He's a big fan of looking at the condition of the plugs. So take the plugs out. Let's get some more light on this. What do we see? Masses of carbon. I'm not an expert, but even I can tell that that's running rich. Masses of carbon, masses of carbon, black, masses of carbon. Go on the other side. Right, this is the old plug. This is just a new one I bought, because the top of this one's bent, but as you can see it's rich again. Now that's a new plug which I didn't buy, that was in the engine, and when you look at it there's no gap. This has been bent over too much. Now this engine was described as running a bit rough when it was last run, so I mean probably wasn't firing on one of the 8 cylinders just there and then, and then rich, really carboned up, and again carboned up. So the engine, we can conclude, at least in recent times, has been running rich. It may be just because it's been run with the choke on. It's never actually been allowed to warm up because it's just been kind of test run. If you look into this, the plug holes, or if you get the light right, you can see on the left, hang on, well, okay, on the right there's a valve and it's closed, and on the left you can just see the edge of the other valve, which also, in fact, if you get it, look, you can see it's open there, just there. like a little curve. You can see the edge of the valve and it's open. So when I manually turn the engine, I would expect that to close. One feature of these engines is sometimes the valves can get stuck in the open position, so I can check for that with a compression test. But I mean, to begin with, I'm just going to look that they open and close when I slowly manually turn it. So you see they are both shut. I suppose that's good, they can't be jammed open if they're shut. And again, those are both shut. I think on the other side here there might be one that's open. Yeah, now if you look at that one, you see the one on the left is closed, the one on the right you can just see the edge of is almost fully open. So I want to check that that does close. Look at these. Yeah, both closed. I think they're both closed as well. And same for that. So I'm going to manually turn the engine and just check every valve. Well, that actually one of those is partially open. Every valve does actually close. Handle from an old scissor jack. You can see it has this thing on the end. Now, funnily enough, if I poke it through here, it will actually engage. It will actually engage here for the where the old manual starter would go, your manual crank handle, and it engages not perfectly, but it does engage well enough to manually slowly turn the engine, which is quite handy. The other thing I'm going to do is just put a little bit of oil down each of these plug holes before I do any engine turning. So to put a bit of oil down each cylinder, of course, on a flathead engine, when you take the plug out, you're not looking at the top of the piston, you're actually looking at the top of the valves. In this case anyway, the piston is here and then the valves are here and here to the side of it. So the from the inlet manifold the mixture comes in and sort of has to flow over the top to get to the piston, and the same with the exhaust. So that's why flatheads aren't particularly powerful compared to a system with overhead valves, even whether they're operated by push rods or an overhead cam. On the other hand, this is the simplest way to engineer an engine, so it kept the cost down when they were producing this, what was in fact a low-cost V8. So anyway, to get some oil into my cylinder bores, I need to squirt it sort of down that way, like that. So what I've got is a lid from a spray paint can full of oil. A lot of my cans don't have lids on because I always end up using them as pots for things, and a medical syringe, and I'm just going to literally squirt a bit down each bore. You just wiggle this pipe into position and then give it a squirt. Some people use automatic transmission fluid, some people seem to just squirt WD-40 down, but I mean, I think I'll just start with engine oil and see how I get on. I'm just a little bit worried now. I'm just wondering, is the reason this plug is pushed down so there's no contact gap because the valve has been adjusted wrongly and it's come up too far and hit it? So what I've done is I put this bit of cardboard in, folded over, and then when the valve was down, and then I hand crank the engine a tiny bit, just watching the cardboard get pushed out until it doesn't come anymore. So I now know, put some light on this, that this valve that you can see, well, you probably can't see, this valve there, you can see it's in the up position. I can now measure how the distance from the top of that valve to the edge of the spark plug hole. If I put this bit of paper down till it touches it, see, like that, and then squidge it against the side, I should get a mark. There we are. Now I can measure that distance from the shoulder on my plug and see if we've got a problem. So the plug would seat about there. So yeah, there's enough spare room for a bit of a gap there to stop anything hitting each other. So I think this must have been dropped on the floor or something and it's just got knocked down. So the good news is I've seen every valve. These are my valves. This is cylinder 4, so I've got 2 valves, and I've seen them both open and I've seen them both closed. and the same for this one. Turn that the other way, so you're facing the side of the engine. Yeah, so every valve I've seen closed, every valve I've seen open, and the ones that are open I've seen close again. So I'm pretty happy. Also, when you hand crank the engine, it actually turns over. You know, it feels alright. There's no graunching or grinding or anything horrible. It just feels like I'm turning over a good old engine like this one. It feels almost the same when you turn it, just a little bit easier to turn. So that's kind of a good sign, I'm hoping. So I've got one of these 160 degree Fahrenheit thermostats here. You can see it's got this little thing here, which is, I think it's meant to allow a little tiny bit of water to come through, because obviously if the hot water's down here and there's no water flowing because the thermostat's shut, it takes that much longer for the heat to open the thermostat, whereas if you've got a little hole, a little bit of the hot water sort of trickles up, swirls around, warms it up, and it should open a little bit quicker perhaps. So I'm worried when this is in place, being held by the pipe, this will get jammed against the side here. So I've actually done an old trick, which is to drill a tiny little hole just there. It's about 2.5 mils, just to be on the safe side. So here you can see I've this holds the pipe on to the manifold. This one I can feel is where the thermostat is, so it's just gently done up just to grip it, just to stop it flying up the pipe. But as I said, I really don't think it's going to fly up the pipe, but I'm not taking the chance. So this is just the simplest, cheapest way to do this. 90 degree bend, stretched out slightly, a little link piece there and a bit of steel tube, because this is all going to be redone anyway. So I'm just using the cheapest tube, cheapest hose I can get off eBay, just to make the thing work. So from an electronics point of view, a lot of people are scared of electronics, but if you just think of it as water flowing through a pipe, that's not quite how it works, but it's good enough for car stuff, I would suggest. So we've got a positive wire from the battery. I've got some fuses on order, fuse just in case I've cocked it up completely and everything shorts out. So we've got a 12 volt line coming in here to the switch. Put the switch on, that puts power to this button, and it also sends power to the plus of the coil, and the plus of the coil is connected to the plus wire, the red wire, to the distributor, and the black wire from the distributor goes to, this is a 12 volt system by the way, goes to the negative of the coil. So that's that. So when you put this on, the coil is energized. You don't want to leave it switched on and not running. The coil will get hot and you could damage it. So what does this button do? When you press this button, it puts a pulse of 12 volts down here through to the, I don't know if you can see it, this tab here. Okay, that then flows through a coil of wire which acts like a magnet, which connects the two big contacts together. This has to be grounded, so it's bolted through to the frame. I've got just to make absolutely super sure everything's grounded, I've got a ground wire to the frame, welded to the frame, running to here, and I've also got a big thick ground wire from there to my battery. So it completes the circuit. I've then got a thick wire from the battery, goes on these big terminals, and if you remember, when you press this button, this acts like a relay. Current through the coil to ground. That coil becomes like an electromagnet which connects these two together. So the in, if you like, is that one. The out, when they're joined together, goes to the starter motor. Now there's no black wire from the starter motor back to the battery, because what you do is you have a ground strap from your engine to the bodywork of your car. So my bodywork is actually this frame at the minute, which is why I've got ground wire to here. There's just a convenient bolt which has all been cleaned up and decorroded, and a ground strap to the bodywork, which means this is well earthed as well. So, you know, if this runs erratically, what I don't want it to be is my ignition system. You know, I want it to be something mechanical if it runs erratically, because you try and eliminate the easy things to eliminate. So that's why I invested in an electronic distributor which has been set up at the factory. So that should be, you know, have the right amount of advance or retard to at least run. So the engine should run on that. And I got a new coil as well. For now the generator is not connected. I'm just going to put a battery on the floor here and run it from my control panel. Again, I've just got a cheapo blingy air filter just to keep dust out of my carburetor. This is my choke, and somebody's attached this bit of wire here. That's the accelerator. I may actually use a choke cable as an accelerator just for now, because you can lock it in position if I just want to run it at, say, a fast idle or something. I'll think about that in a minute. So steps to go. A final double check of the wiring. It's always best to check more than once. Put the fuse in there. Finish off the other radiator pipe. Fill it with water. Hopefully water doesn't just drip out all over the floor. Fit an electric fan here. The plan would be, if this works, is that the thermostat's open at 160. When it gets to about 180, the fan thermostat would kick in, or I'd just have it manually operated with a switch. I'm not quite sure yet, but so I may just stick an electric fan on there as well. Once I've done that, probably take the plugs out, spin the engine on the starter briefly, just check for compression on all the cylinders. If that's good, put new plugs in, because these are quite fouled even though they don't look like that old. Again, I'll give myself the best chance. They're not that expensive actually. So some new plugs are coming, put them in, and then almost ready to go. This is just my temporary exhaust, but as you can see I managed to buy these flanges which actually fit with a little bit of filing to get the holes oval. One of them I had to cut out a homemade gasket, and then I've used 90-degree bends, 45-degree bends, Y connector, then up under the engine, out through the back of my homemade frame through just the cheapest silencer or muffler, as you may call it, that I could get online, and out the back here. So here's one of my electric fans. They're actually very inexpensive online, which is a bit of a worry. I'm not sure if they're total junk, but I just need a way of fixing it to my radiator. I don't really want to put the cable tie plastic things that come with it through my radiator core, which is probably pretty fragile anyway. So you'll see I've got some coat hangers. They're pretty rubbish coat hangers, but if you want some wire, they're actually great. So I'm going to try and wire it on temporarily. Right, I bought some new plugs because, to be honest, they're not very expensive. The others were pretty fouled, so I might as well just give myself the best chance of a decent ignition system at least. So these are NGK. They're recommended as being better than Champion. APR6FS. They have apparently, compared to Champion plugs, they have like a softer thread which is kinder to the heads. If you've got alloy heads, you're supposed to use an anti-seize compound on these. For the gap, most people recommend 0.025 inches. If you've got an electronic ignition, you could go wider. If you've got, as I have, a sort of electronic points, but I've still got a normal distributor cap, if you have a wider gap than this, some people say on the forums you can get arcing around inside the cap. So I'm just going to stay with the smaller standard conservative distance, which is 0.025 inches. Seeing as I'm in a metric country, that works out at 0.635 millimeters. I have a metric feeler gauge, and we got 0.6 millimeters there. So I've been gapping my plugs just adjusting the gap to just a loose fit on the feeler gauge at 0.6. Okay, quick test of the starter solenoid. So I haven't got the thick wire connected to the starter. Okay, that seems to work. This is the homemade gearbox oil filling system. Don't laugh, it works. Okay, we are, gearbox is full. Right, so I'm all set up now for a quick spin on the starter motor with the plugs out. I've also got the coil attached to a spare spark plug here just to see if we get any sparks. Should be good to see. The battery's down here. We've tested that the solenoid engages, so something should happen when I press the start button. Here we go. Oh, okay. Again. Okay, well, nothing's actually fallen off. I'm going to quickly check for compression by putting my thumb over these holes as well, and I think just to be on the safe side I'll put a glove on first. See it farting out past my so we've got reasonable compression that side. Let's just try this side. We are getting ready for the first test run. I'm just using this gadget. It's quite a handy way of carrying water to your radiator, and then you just pull this little obturator thing out of the middle and you just slowly let it fill up. And I'm just looking to see if there's any water pouring out onto the floor. That's not from the radiator, that's me just spilling it earlier. Alright, I filled it to the top pretty much. There is actually a drip just here, but it's right near the top, so it's very slight, so I'm just going to ignore it actually. I'm all wired up. I'm just going to check the switch to this fan here. Just double check it is spinning the correct way. Well, which is the correct way? I'm actually using it as a blower. It's coming down. Come on. Yeah, that's definitely blowing air through the radiator. Of course, I don't have a shroud on the radiator really, so I'm only blowing air through this part, not the whole area. And also the radiator is quite silted up, so I don't actually know how well this is going to work. But it's much better to run the engine with water in it than nothing. Now, I got the idea for this boat tank from Vice Grip Garage. I've got it mounted on a block, so the fuel pump doesn't have to try and draw it uphill. It also comes with a squeeze bulb. So my plan is to use the squeeze bulb to prime it, check for any leaks on any of these connections, and I need to get some fuel into the float bowl. So basically I'm going to just prime it till I can just smell some fumes, and then I'll let the mechanical pump do the work hopefully. So here we go. Give it a squeeze. I'll also just listen as well. I might be able to hear it coming through. Yeah, you can hear the float valve sort of popping off. Hear that? Ooh. Right, there's fuel in the bulb now because the feel has changed. Let's have a sniff. Let's just see what happens if I blip the accelerator. I might give it one more squirt. Ah, I can hear it squirting. Hear that? I think I saw a little bit of petrol then. Ah, you see a little bit of...
Yeah, I saw it.
Right, I don't know if you could see that. A little bit of wetness came out there when I blew the accelerator, so I've basically primed the inlet manifold with some vapour, hopefully, so it might start. We've got a little bit of choke. Accelerator, no idea. Let's just see what happens. Okay, ignition on. Starter on.
Bubbling around your spark plug, John.
So you can see there's a little bit of leakage here.